Yeah, hello everyone, Berlin this side. So today our main agenda is to improve the way of speaking, and the second most main agenda is to improve the way of articulating how well I can convey my point of view to others. Okay, and also the fluency. And in the process, if I'll go through the process, I might be having good skills in the essay also. So today's main topic is about linked list. Linked list basically is a data structure which we majorly uses in data structure and algorithm. So in lead code, we'll be practicing this linked, linked list section. What is it about? Imagine you're having a task where you have to maintain the data entry of cars entering a parking lot. Since the number of cars entering will be different and may change daily, which means like if somebody is going to office, then it's not necessary to go from one route. He can change his routes according to the traffic and according to the time which he has having. So yeah, that's like linked list introduction, and then constructing a fixed size data structure like an array might not be helpful. Yeah, the same way I was talking previously that it's not like fixed path. It changes. It might get helpful if we change the path, like not change the path. Yeah, changing the path, but the goal is same. So this is when linked lists come into the picture, which allow us to add and remove cars easily. Unlike arrays, linked lists have a variable size and can modify it to our needs. Like if you have created an array of certain length, like if you have created an array called int arr, array of integer type with fixed length approximately 10 block of array, so which means your array is fixed. You cannot change the length or the size of the array. But in vectors we have the ability to change it, but we are not talking about vectors here. We just talk about arrays, but the case we are using here is linked list. So I think if we will use linked list, also the main, what can I say? The main importance of using linked list over arrays is that arrays do have contiguous memory allocation, which means the elements will be stored in a contiguous manner. Like you cannot store or insert or delete any operation do on arrays on a random basis. You have to go through the whole array. In that case, time complexity comes in a place, and time complexity gets bigger and bigger, which is not optimized way to approach a problem. So here we take example of linked list. So it is a linear data structure that can be visualized as a chain with different nodes connected. In linked list, we having the node and the previous pointer. The previous pointer points to the next. We having node and the address of the next node. In that node, first will be point the value, and the last will be the address of the next value, and the first one will be the null pointer. I don't think I've told it correctly or not. Let's take an example here. Since for element to be added in an array, we need the exact next memory location to be empty, and it is impossible. Yeah, the same way I was talking about previously that in array we cannot do these such kind of operations. So here we using a linked list. A linked list is a data structure containing two crucial pieces of information, first being the data and the other being the pointer to the next element. First being the data. In linked list, we have the one in one node we having the two sections called the one head, which means the data of the node, and next called the pointer, which will point to the next element. So yeah, here we take a look in a picture that we having here we having a node A called head node, which we having data as a 0. Then we have data as 1 and 2. And 2, the next pointer of the 2 node is pointing to the null, which means here node will end. Linked list will be ended. Creating a linked list, there are two informations that to store at every node. Thus, there is a need to create a self-defined data type to handle them. What it depicts that there are two informations to store at every node. Thus, there is a need to create a self-defined data type to handle them. Self-defined data type to handle them. Let's take a look more. Therefore, we will use the help of the struct class and classes to learn about struct and classes. You can refer to this. Okay, here this guy is talking about how we can use linked list in data structure and algorithm. In C++, we can use class and using a struct keyword, which we have studied in C++ also, that how we can use struct. We will not go for Java as we are only doing this in C++. We will not go for Java language. We will just go through with the C++ solution. Here what we having class node, which depicts the strict keyword. Class node, we have implemented the access modifier. Oh, all right. Here public we are using as a access modifier, in which we having the int data, the data value, node star next the pointer. The uh, the implementation or the syntax of linked list is like that we need to first define a class and the name of the class. Let's take an example. Here we use node as a class, and first we need to put a access modifier that it is public or not. uh, there might be some confidential information about the company, so we will not take everywhere that public. We must use the protected and the private here also. If we are if we are talking about the production level, then in that case we will be using the private access modifier. But here we just but in private there are many things that we cannot access. For example, if we use private here, then it will give error to us, which will not be nice for our program. So here we only use public access modifier, and there we having int data. Int data means the data value and the class node to the next pointer value. Yeah, here we added one most important thing, the pointer, which will point to the next value. In our node, we having node as a pointer, and the pointer name is next, which will point to the next node of the linked list. And then again we put public here, then we are doing constructor thing, node in data one, node one, next one. Data, so the initialization is like this, that data equal to data one, like the data equal to data one. Initialization, yeah. The data we first use the data, first initializes the data value, which will be the actual value of the data one. which is present in that node. Then the next depicts the next data, which will point to the next value of the node. Like if we having the pointer here, next it will addresses points to the next value of the node. So the pointer we having the address of the next node. With the help of that, we can actually find the value of the next node also. Yeah, that's it. And they be having in data one or initializes providing. I think we having only two type of nodes. Yeah, we having two type of nodes, int main, and here we taking vector because we cannot take a fixed size of a array here. Yeah, there we having vector int ARR of 258 or y could node ARR count y returns the memory value. Here we getting a bit confused about the vector we taking here for the sample case and node y taking the node array of zero index the memory value and y this pointer. Here we using y as a this pointer to the data. Returns the data stored at the memory point. It will return the data. Okay. So in output we will be having y, which is the new node, the array one. New node will points to the this one. So here we having the address of this node data value. Here we having one, and the address of this one is this one, hexadecimal number. As we know that compiler stores the address value in hexadecimal number, there we having the header hexadecimal values, and as a output we depicts the value of this pointer. Y means here the two, and in two pointer we will be having two this pointer data. Yeah, that's it. Let's break this example to understand how it works. The struct has two data types which contains the value of the node and a pointer next, which points to the next node in the list. There is a constructor which assigns the value to a new node. A new keyword is okay. The new keyword is mandatory. It's a constructor or is a constructor which assigns the value to a new node. The new keyword is used dynamically. Okay. Why we use new here is because we having the dynamic vector here, which might be extended in future also. So they'll be using the new keyword to allocate the memory space in a dynamic manner. Like in future, if we want to insert more values over here, then we can use this new keyword to dynamically allocate the memory to a node. Okay, to allocate the memory. All right. The combination of the given parameters and functions initializes the linked list. Okay, so basically the whole code here we have understood is that the how we can initialize and how we can use linked list in our programs. It's nice to have the understanding of the pointer. Also, if we have the understanding of the pointers, that will be more beneficial in linked list. In most of the cases, we will use only pointers. Like in array also, we have in binary search used most of the two pointer approaches. Like first pointer is moving and the another pointer is approaching that. Yeah, that will be most beneficial if you have known about it. If you don't have, you should go through it, and it will be more beneficial to you in linked list also. Understanding of pointer. A pointer is a variable that stores the memory address of another variable. In simple terms, it points the location in memory. So basically, the main important work of the pointer is to points to the location in the memory where data is stored. This allows you to indirectly access and manipulate data by referring to its memory address. Okay, it directly points the memory address directly access the manipulate. Okay. Indirectly, we can access the data by just referring to the memory address. Yeah, that's it. There we having the main function. Main function we having the integer type data type access to y, and here we're checking the address of the x in y, and yeah, y references x. You simply take anything. Class we having another class. The understanding between the differences between the node and node pointer. Node refers to the structure that contains the data and the pointer in the next node. Okay. In node contrast, node pointer specifically denotes the pointer variable that stores the address. Okay. Node basically refers to the structure of the class. Simple. Yeah, that's it. And in node pointer specifically denotes a pointer variable. We having a node star means pointer variable, which will point to the address of the node. Here we having the next. If we use next over here, means we are using the next pointer over here. That's it. Same way using here. Memory space. Then we having the memory space thing. Let's talk about assuming the data stored in integer. Another main difference between an array and a linked list is the memory used. In case of array, we are storing 4 byte of each memory, whereas in linked list, we are storing data and a pointer at every node. So memory used up will depend on the configuration of the system. Okay. Memory basically depends on the configuration of the system. For 32-bit system, I don't think so. Now people use 32-bit system. Now everyone is using 64-bit of system. So basically you can say that integer takes 4 bytes, pointer takes 8 bytes, overall it takes 12 bytes. So linked list takes 12 bytes of the memory space. Hypervisor consumes more space. Divisions of linked list. Creating a data structure serves as a foundation or building of other dynamic stack and queues. Use memory allocation and as on linked list to manage and allocate memory blocks efficiently. Web browser is one of the most important application of linked list. Yeah, web browser. Yeah, like in web browser, we having the nodes. The address of this website points to the next node of the website. Yeah, in website also, in browsers also, in web browser also, we use linked list. Types of linked list. Yeah, that's the most easiest part of the linked list, that we having a singly linked list, and doubly linked list, and circular linked list. In singly, we just having the normal linked list as we have go through previously, that we having a node. For example, let's take a 3-node linked list in a singly linked list. Take an example, we having data and the address, and the data and the address same, and last point to the null node. And in doubly, we can backtrack in both directions. Just that it. That's it. Like if we want to go back in a list, here we have just a one more added pointer that in each node points to the both the next node and the previous node. Like in this, we can do a backtracking case, which will be learning in future. So in backtracking, what's the case? Like we can go forward, also we can go as backward. Like we having the backward and to the null and the forefront and to the 1, 2, and 3, a doubly linked list. And then at last we having the circular linked list. In the circular linked list, the last null point will be points to the first of the node. Yeah, that's it for today. I guess so. Thank you for staying tuned with me. That's it. Thank you. Thank you.